I'm going to put on a presentation of the cement plant at the Historical Society again. And she said, well, that's a good idea, but why don't you start where cement first started? And I said, that's a very good idea. You do it. She said, no, I don't have any interest in cement, but she did it. And many, many nights until midnight she was studying. Every day, nearly she'd go to the library and get the information. So turn it over to my wife, Chris.
Yes, he's right. When he said, why don't you do it? I thought, no, I don't want to do that. How boring is that? I don't care about cement or concrete. It doesn't interest me at all. But I thought, he said, do it anyway, and I thought, oh, okay, I'll at least look into it. Well, as I started to read up about it, it turned out to be an incredibly fascinating subject, and it really got my interest. So, here we go. So, before I start, this is just a map of ancient sites that have structures, buildings, whatever, with cementous materials in them. So it just shows you in the ancient world the scope of it. It was quite a long time ago that it was discovered. So concrete and cementous materials is actually a natural thing. And they discovered this in Israel, a site 12,000. You know, it's withstood 2,000 years quite well. Wow. All right, this is the Palace at Knossos, which was all concrete and paint and limestone, and it dates back to about 1500 BC. Hanging Gardens of Babylon, again,
wow.
done with bitumen. They were bricks that were held together, and they made waterproof canals, they made pipes, all this was fed by water, which they brought in quite advanced. This is the Pyramid of the Sun in Teotihuacan, and it's also made of concrete and limestone and all, and has withstood time. Now, we do not have the city that used to be Mexico City that the Aztecs built, and it was an island off the mainland, and they needed to pipe water. So they built these beautiful causeways, which are described in ancient Spanish manuscripts. When the Spaniards came over, they described what they saw, and they would pipe in waterproof aqueducts their causeways, their water onto the huge city. But the Spaniards destroyed it completely, so we don't have any pictures or any images of it. Okay, now the Great Wall of China. It was built partly, it started with big mounds of dirt, but then that didn't hold up as well, so they went to concrete and cement, and their quality control was really strict. The superintendent on a section, each mason had a section of the wall. And when he finished his section of the wall, the superintendent would take his drill, and if he could drill more than an inch into the wall, he would flunk the quality control, and the mason was killed on the spot.
Oh my God.
So there was pretty good motivation and do it right. And this wall is 6,000 miles long. And they estimate that one man died for every yard of that wall. So there were a lot of deaths. I don't have a picture of it, but the Grand Canal of China was another huge project. It was, think of the Panama Canal, which is like 20-some miles. This is 1,200 miles between the Yellow River and the Yangtze, because they both run east to west, and the canal runs north and south, and it was to join the rivers for travel and moving supplies. And 2 million men died on that project. They kept scrupulous records, and life was pretty cheap, I guess. But they accomplished amazing things. All right, this is the stupa in India, which at one time was covered with completely white, gleaming concrete shell, the dome. Now, over the years, there was a lot of work with concrete. And I have to make a little disclaimer here, because I was born in Rome, so I'm just a little bit prejudiced. But the Romans are the ones who took concrete and cement to an art form. It has never been duplicated to this day. They don't know how they did it. They don't know what they did it with. They have some guesses. They're guessing it wasn't all about materials, because back in these ancient days, materials were expensive, but labor was cheap. So the people power, today when they mix concrete, they take cement, they take sand, rocks, water, they mix it all up and pour it, because it needs to be quick, because labor is so expensive. But back in the Roman days, when they laid a concrete structure, the slaves would, each rock was laid by hand, perfectly symmetrically, vertically and horizontally, and then the cement was tamped almost dry, because the drier it is, the stronger it is, because when it's wet, air pockets get in there and that weakens it. Today our concrete lasts about 200 years. Roman concrete has lasted 2,000 years and still is going. So they would tamp it till all the air was out, and then they would do the next line of rocks, vertically, horizontally, tamp. So there's no way we can do that today, but they did. And these were okay. This is the Roman, one of the many Roman aqueducts. Now Rome was a very large city back in its heyday, and they used more water per capita then than they do now in present-day Rome. Romans loved their water. They loved their fountains. They loved their baths. And they had it down. I mean, if you were wealthy, you had water piped into your home. You didn't have to go out to the well. You know, it was piped right into your home. It was hot and cold. They really used a lot of water, so they would have to bring it in from the Alps or other places where there was a lot of water. And these are all, the rocks are just fitted together. They don't use concrete on this. This is all just stones perfectly placed, and they get tougher and harder and stronger over time. But at the top, along here, they had concrete waterproof like canals, and the water would come, and they had it perfectly angled, so it was just a steady gravity flow into the city. This is the harbor at Herculaneum, and when archaeologists first checked out this harbor, they were sure that the harbor was made of big carved out blocks of granite or some heavy rock. But when they got down in the water and examined them, they were concrete. And the Romans had figured out how to make concrete that would harden underwater. And so they didn't have cranes or any of that. So what they would do, they would make a thin shell of concrete, like a big concrete box. And they would float it out to where they needed it to be. And then they would keep filling it with concrete until it sank in place where they wanted it. And they'd just keep going until they had it built. This is the Colosseum of Rome. And just for size, it held between 50 and 73,000 people. And just to put that in perspective, University of Phoenix Stadium holds 63,000 plus. So it was huge. And these arches here were all made of concrete to support the weight. And here's an aerial view of it.
Wow.
And this is the absolute pinnacle of Roman construction. This is the Pantheon of Rome. It was built in 112 AD by Emperor Hadrian to honor all religions, because at that point they were still very tolerant. And all religions were welcome, all gods were welcome, and people could come in and just worship whoever they pleased. This dome is made entirely of unreinforced concrete. And to this day, engineers have no idea, first of all, how they could do it and how it's still standing. This building is still used as a church today, as a Catholic church. This is what it looks like on the inside. What they do know is that on these lower sections here that had to carry a lot of weight, they used like heavy volcanic rock. But as they went up, they used lighter and lighter rock, and this dome here, the aggregate they used is pumice, which if you've ever felt pumice, how light that is. It's strong, but it's light. So, yeah, that was, and it's still in great shape, still being used today. Now, one of the things that the Romans, an engineer was wandering through a village near Vesuvius, about 200 BC, and he noticed that the villagers had lined their houses with this plaster that was just so much tougher and more durable than most. And they asked, what are you doing here? Well, they were taking the ash from Vesuvius. And it was, that's where the word pozzolan cement comes from, that has ash in it, and that gives it a strength that exceeds the normal. Now, like I said earlier, the Romans loved their baths. They loved them. And when they talk about, these are the baths at Caracalla, but Roman baths were the size of a city. Think about the Cottonwood Rec Center on steroids. This was the gathering point where everybody in the city could come, and they had a huge atrium, and they had pipes that would bring hot and cold water. They had baths that were hot, they had baths that were lukewarm, they had baths that were cold. They had steam rising up so that even in the middle of winter you could sit in the atrium and relax and be warm. And of course a lot of waterproof concrete went into the building of the baths and the pipes that bring it all in. So it was a favorite gathering place of people. Okay. Now, after Rome fell, 400 AD, Rome collapsed. And all the technology was lost. There's no more record of any concrete or cement building after that. Now, there have been magnificent buildings built, Notre Dame, the Hagia Sophia in Istanbul, other structures. Now, this is Hadrian's Wall. Now, this is in England. They did not have access to the Vesuvian ash, so they just had to make do with crushed tiles, crushed rocks, whatever limestone they could find. And so obviously the wall did not hold up like those other buildings. But it was said that the standard of living in southern England, where the Romans had taken over, was not matched again until the 1800s, because they had central heating, they had hot and cold running water, they had toilets, they had all of that. But after Rome fell, it all collapsed, and it just was lost. And then in the 1700s, so 1300 years went by before there was a need again. By this time, Britain was the ruler, was the empire that ruled the world, and Britain had Canada, they had Australia, they had India, they had all this distance they had to cover with shipping and supplies, and they were losing way too many ships on the rocks and storms and everything, and they realized they needed lighthouses, and they needed some substance that they could use to build those lighthouses that would withstand water and wind and everything. So then the interests of government and the interests of business merged, and there was a real push to come up with concrete or cement, because they knew it existed. They saw the Roman buildings and these other buildings, so they had to rediscover it. So in 1779, Bry Higgins was issued a patent for hydraulic cement, and that was stucco for exterior use. And then in 1793, John Smeaton found that calcinating limestone with clay and crushed gave him a lime which hardened underwater. So that was a big first step to get these lighthouses built. And then in 1796, James Parker patented a natural hydraulic cement. And then the person who's credited with modern cement is Joseph Aspdin. He invented Portland cement, and he called it Portland cement because when it hardened,
I'm sorry, we have someone out here who needs an application for the craft show, and I can't find them.
They're right behind the desk.
Okay, excuse me.
that's all right. So anyway, in Portland, England, there was a rock that was beautiful and kind of white and all, and the concrete that he came up with looked kind of like that, so he called it Portland cement. And from there were three important developments that happened to move cement and concrete forward. The first was the rotary kiln. Up till the rotary kiln, when you made your cement, you had to do it in batches. You'd fire up, you'd load up the kiln, you'd fire it up, you'd heat your limestone, then you'd wait for it to cool down, then you'd take it out, you'd grind it up, and it was very time consuming because you have to wait for it to cool down and then you have to heat it up again. With the invention of the rotary kiln, it was a constant 24-hour-a-day process. You never have to shut it down, and you could make a lot more of it. So it was invented in England in 1886, but it never really took off there. But then American entrepreneurs caught sight of it, and they brought it to the U.S., and this unknown guy named Thomas Edison perfected it and got the patent on it, and it was a big success from there. And the other thing was, they had a real hard time using concrete and cement because it hardened too quickly. They couldn't get it to form the way they wanted it without it hardening. And the addition of gypsum to that gave them the time. Then they had a little more control over the amount of time before it hardened. And then the third thing was the invention of the ball mill, which made it possible to take the clinker, which is what you get after you heat it, and grind it into that fine cement that we have now. Now the other problem they had with concrete or cement was that when you had a freeze and a thaw, it would crack. Well, that's not really good if you're building a building or a road or a bridge. As soon as it freezes and thaws, it cracks. And that doesn't do you any good. Quite by accident, someone had accidentally dumped a lubricant into a batch of cement that they were making. And when all that went through the process, it formed what they call it entrainment. And this batch was used then for concrete, and they found out that this particular batch didn't crack when it froze and thawed. So, what's different here? And then they discovered what it was, and so then they intentionally started adding that. Now, when President Roosevelt started the infrastructure projects to make work to end the Depression, when they started making these big dams like the Hoover Dam and the Grand Coulee Dam, they needed a lot of concrete. So that really got the industry going, because then more and more refinements were made. There was a use for it, so that happened. The other one was when President Eisenhower decided to build the interstate, highway system. A lot of concrete. So before we start with coming to modern times, just to get in perspective how new this really is. It was old for Rome and the ancients, but then it all died out. The first concrete reinforced bridge was built in 1889. The first concrete street in the U.S. was in 1891 in Ohio. The first standardized cement test didn't come here till 1900. And the first concrete high-rise was built in Cincinnati, Ohio in 1903. Now, in Carthage, you might have heard of Carthage. It's where Tunisia is now on the coast. The ancient city of Carthage was kind of like Singapore or Manhattan. It was the trading spot of the Mediterranean. It was the place. And everybody wanted to live inside the walls of Carthage because it was safe and it was a very affluent, very rich city. And they ran out of space because there were walls and they didn't want to have to knock the walls down and go out. So they went up. They had 6-story apartment buildings in Carthage back in ancient times. Unfortunately, we don't have pictures of them because Carthage got a little miffed when this upstart Roman city started growing. So they decided this is the elephants. Hannibal took the elephants. They couldn't do it by sea because the Romans were masters of the sea at that point. But they took it around to Spain, went up through the Alps, came down, had a big battle with the Romans on the grassy plain and won that battle. And would have gone on to Rome, except that there was trouble at home, so they called Hannibal back because they needed to deal with that. Well, they made a big mistake because the Romans got really miffed and they thought we need to put an end to this. So the Romans sailed to Carthage, leveled it, burned it to the ground. There was not a trace of the old Carthage left, and then built their new city on top of that site. But anyway, so we finally got around to the first high-rise in 1903. Now, if you remember the Pantheon, the beautiful dome, the first concrete domed structure in the United States was the sports stadium at Champaign-Urbana in 1967. So now that we've come to modern times, I'll turn it over to Don. It's all yours.
You done?
Do you want the light on, Don?
It don't make any difference. I guess there's film there to show too.
Yeah.
Is there any questions with Chris?
Oh, she did a beautiful job.
Ron. We'll need
Glen Canyon Dam and American Cement, which had 2 plants in back east in Pennsylvania area and 2 plants in California, they got the bid. And then they didn't know what they were going to do. Well, if they tried to furnish the material from their 2 plants in California, it was going to be a long trucking deal. And they didn't know whether they could even do it, so they ended up buying Halliburton out as far as the ground there on the hill. And they put in a cement plant there in Clarkdale. Well, when they put it in, they put in 2 kilns because their intent was just as soon as the Glen Canyon Dam was done, they were shutting her down and moving her out. So they put in every old equipment that they had anywhere in the nation. They put it in, and 2 kilns and ball mill. Everything was as old as they could get. Well, for the first few years, there was no such thing as buying any material, anything to repair something with. We need to repair something, we just repaired it with whatever we could find to repair it with out of the scrapyard. And the kilns at that time, this is a picture of one of the kilns here. It was 350 foot long and about 10 foot in diameter. Well, the sales got to being so good in 62, they put in the 3rd kiln. And that gave them about 750,000 ton a year of cement. Well, there was enough cement, just jumping forward there a little bit, there was enough cement concrete poured in the Glen Canyon Dam to build a 4-lane highway from Phoenix to Chicago. Can you imagine that? That was a lot of cement. But this is a picture of chains that was inside the kilns to break up the clinker that come down, break up the chokes and also to hold heat in there. The kilns had to burn that material at 2,750 degrees and it would liquefy it, and then it would line the kilns and let it come on down and become clinker as it come down to the coolers. But anyway, the quarry is right above the cement plant. If any of you, I know all of you has probably seen the plant, and one of these tanks here exploded one night, and when I came to work that morning, there was cement all over the parking lot. There it is. There it is.
Oh, no.
What it was, they needed additional storage, so somebody put in some grain elevators, and they didn't hot hole cement. But anyway, the quarry is above the plant. When I first went to work there, well, when the plant opened in '59, I went to work there in October of '59. The first cement went out of the plant to the Glen Canyon Dam on the 7th of November of '59. And we loaded trucks out of there about every 15 minutes, day and night, 24 hours a day, 7 days a week. So there's lots of them. And at that time, the trucks had to go through Clarkdale, downtown Clarkdale, through downtown Cottonwood, up through Sedona, and up Oak Creek Canyon. And what got me started doing this cement plant deal was they can't do that anymore. Believe me, that won't happen anymore. But we was talking sometime at a meeting, and there was a guy who said, I drove Oak Creek Canyon every day for years, and I'd never seen a cement truck go up there. Well, I think the reason he didn't say a cement truck, he was thinking of concrete trucks, the rolls, not a cement truck. I got to think about that later, and I really think that he was thinking about concrete trucks, but he had to meet cement trucks. But we'll go back to the quarry now. Yeah, that was one of our wrecked trucks. That truck come out of the quarry. A mechanic had went up to get it because there was a little problem with it, and he come down. He didn't realize the truck was loaded. He came down and he went off that hill, and I don't know how deep that is, but it's a damn long ways. When he come off, he turned a somersault and landed on his wheels. He left his load, he left the radiator, and he was not hurt. He crawled out of it and went to the garage and went home. This here is a stacker. I'll just kind of go along with the pictures here. This is a stacker, what we call a stacker. It's two big arms, and it stacks the material up and down the bays there. And it evenly stacks everything. Our bays, when we first started there, we had 4 raw bays and we had 4 clinker bays. The clinker bays would hold about 11,000 ton each, so we had 44,000 ton of storage. Now the 2 domes over there hold 120,000 ton, so there's a little bit bigger storage. But when I went to work there was 5 ukes that hauled material down. There was 35-ton trucks, and I drove truck for a little while, and until I got in the maintenance department, and we would just constantly up and down that damn boring hill. 35 tons at a whack. But now their trucks are 100 tons. Before I left there in 58, 57, when I left there, they had 60-ton trucks, and now they're 100-ton trucks, but they're only running 4 of them, or 3. I don't know whether there are 4. But anyway, I think I said in '62 that they put in the 3rd kiln. Well, American Cement sold out to Gifford Hill out of Texas in somewhere in the 70s. I don't know just what year it was in the 70s. They sold out to Gifford Hill. And then Gifford Hill sold out to the Pima Indians in 87. they sold out to the Pima Indians in Maricopa County. So they own it now. Well, in '02, this is a warehouse where they store the sack cement. At that time they could sack. They had sack behind the spouts. The spouts, there's 4 spouts, and you just slid back and forth on a slide and sticking sacks on it. If you ever looked at a cement sack, there's an opening in it where you can put a spout in it. And they'd automatically fill and automatically kick off if they didn't explode and cover your. And I've seen it done. I've never sacked a sack of cement in my life, but I've seen some of them explode. And they wilt up. I jump back and forth here because look at that. I guess I shouldn't look at that. But the material comes off the hill, and at that time it came off the hill in chunks as big as this desk here, or bigger, and comes through the primary crusher. The primary crusher, the big jaw crusher, it just works on like that. They've got a stationary jaw and movable, and it just eats it up kind of like chewing gum. And sometimes they get a rock in there that was so big. I think that's the first truck that went up to Ben Canyon Dam, I believe. Sometimes it'd be so big that they couldn't get it started, and we'd take a hook and hook in there and maybe turn it over and get it started. So sometimes they'd have to blast it. But now they've got a different system of drilling and also blasting, and I don't think there's a chunk comes out of there much bigger than a suitcase, and it goes through the jaws faster. Well, it comes through the primary crusher and then go on up to the storage area, and then go on to the secondary crusher, which the primary would crush it into about 8-inch diameter, and then the secondary would crush it into 5/8 rock. And I think Chris has got all these here,
Going around.
and she'll pass them around. The 5/8 rock would go out into the storage area, and that stacker there is stacking. Well, I think that particular one is stacking clinker, but the raw stacker is exactly the same stacker, just on the other base. But I'm not like Chris. I can't read my notes because I can't see to read.
We're all the same.
I've got stumbled through it here. Are you gonna shut me off? They gotta shut my mouth?
So it doesn't distract you. We're already through the first run.
Oh yeah, right. When it goes through the secondary crusher is 3 rows of hammers, and them hammers are 360 pounds a piece, and they're double hammers on a shaft, on a 3-inch shaft, and they spin. And when it spins, it breaks all that rock up, and the rock is limestone, as she said before. It's all limestone, and it breaks it up, and then it goes through. And every hour, every bit of material in that plant is checked. The samples taken to the lab, and it's checked for everything. We have the best quality control, and they don't kill you. They don't kill you if you miss it. But we have the best quality control in Phoenix cement of any plant in the nation. And they have won several awards. Chris can tell you the awards. I don't remember what they told us, but they have won several awards for very, very good quality control. And now the Pima Indians bought it, and they signed the contract on it May 4th of '87, and there was in our contract, we had a union at that time, and our union contract, we had in there 30 years and out, regardless of their age. You retire at 30 years. Well, the Indians, after they bought it, in about November, they started talking about letting higher paid guys get out and give them 2 years. If they had 28 years, they'd give them 2 years to get out. Well, I grabbed mine and run. I had quite a discussion with the plant manager at that time. no, you don't want to leave, I said, I'm leaving. And I told him the other day I had, at our presentation in Clarkdale, he was there, and I said, I've ate every damn day. But that was the best birthday present I ever had when the Indians signed up. That happened to be my birthday. So they was going, in 202 then, the Indians was going to put an expansion in and change things around. And they had scheduled, figured on $200 million. Well, before they got through with it, they spent $280 million. But they took out the 3 kilns that American Cement had put in. They took them out and put 1 kiln in. It's only, I don't remember, about 60 foot long, but it's a lot bigger around. And they put in them, I know all of you have seen the big tall tower. Well, that's a 5-stage preheater. The material goes in the top of that preheater at 200 degrees and comes out at the bottom at 2,000 degrees 15 seconds later. So on the way down, it's heating up pretty good. Well, when it hits the kiln then, it only has to heat up to 750 degrees to make clinker. And
this is what goes into
and the only thing, and when the Indians bought it, they also bought the gypsum plant down in Clear Creek so that they would have no problem with getting gypsum. Because gypsum is very important in the cement. There's only about 3% gypsum, but that 3% is important. They also use fly ash, and they've been getting their fly ash from the the power plants up Page. But due to the fact of all the shutting them down and everything, well, they're trying to find a place where they can buy have fly ash of their own and not have to depend on somebody else for fly ash. And they bought a piece of ground up in Utah, I was told, thinking they had it, and then they found out they didn't. So they got a piece of ground up in Utah that they really don't need now, I guess. But
I'll take it.
what's that?
I said, I'll take it.
Yeah, well, I got a piece of ground in Utah, I'd sure trade for it. And I'm sure they're not going to trade me. But the ball mill, after the raw material comes out of the secondary crusher, goes into storage and then it's taken into the ball mill. And I don't know how slurrying that raw material to Phoenix would have worked, because the raw material is very, very abrasive, very extremely abrasive. And shoots and everything wear out fast. The ball mill is lined with big, heavy liners in there, and about once a year we'd have to change all them liners out. Shoots, you're constantly repairing them. There was no slow up on that.
so this is what the
But it might not have been so abrasive when it was wet, I don't know.
inside the ball.
But it comes at the end of the ball mill, there's that 5/8 material, and when it goes out of the ball mill, it's powder like she's got a jar of
This is what happens.
raw material there somewhere.
Balls.
Finer than water. It comes out of there finer than water. And the ball mill has got 90 ton of balls in it. And every week, when I was there, every week we'd have about 5 to 7 tons of balls added to it, because them balls would wear out. And I got one ball here that
I just,
Yeah, we
got
has a ring around it.
oh, no, that was up there.
I working in there one day and I found this ball here, and it just always excited me. There's a bearing race wrapped around that damn thing, and it's never been hit with a hammer. It just rolled with the balls, some way or other. It did. I dug that out of there probably 40, 50 years ago. It just enthused me when I seen it.
There's a ball inside a ball.
But that's how fast in a week's time there'd be 5 to 7 ton of balls wore out. little bitty balls and little, just, dispensers, as we call them, in there, and we'd have to dump it and screen everything, and screen all the little stuff out, and recharge it. But, so, it was very abrasive. Now, the finished material, after it goes through the kiln and it becomes clinker, is not nearly that abrasive at all. The finished material, the finished ball mills has just as much, many balls in it, but it didn't wear them out so fast. Very seldom ever have to put any more balls in there. Then it goes back into the kilns, and it comes out as clinker, as she showed you, and then goes into the storage area again. And at that time, they had 4 bays. So like I say, it was 11,000 ton of bay. And after the Indians bought it, they put in them domes, and all the material goes into them domes now. And they hold 120 ton between the two of them. So anytime that clinker got wet, it damaged it to a certain extent. It didn't ruin it, but it damaged it. So it goes in there, and now it's completely dry. But all the material all the way through is quality control, and as far as I know, nobody ever got killed out of it. Thank God for that. I brought that the first one down. But anyway, that gives you an idea. And I'm not going to go too much of modern mills and whatnot, because I don't know that much about the modern mills. They've told me, but I can't make notes and I can't see. So I do know that they've got a plan. They've got a plan right now for a new finish mill in the future, but it's a $60 million plan, and they're not going to do it in 1 year. It's going to be a 2-3 year program. The gearbox on the new mill that the Indians put in is terrifically big. It takes a big, huge truck. He told me how many tires was under that truck just to haul that thing. But it's huge. The first truck, like I say, the first truck went out of there in November 7 of 59, and they finished it in 64. So there was about 4 years of constant trucking to the Glen Canyon Dam. Our own local, he's dead now, but Bill Helm, he used to live here in this area. Some of you probably know Bill Helm. Drove the last truck and had a big article in the paper when he delivered the last load up there.
Yeah. Well, then they built the bypass. Yeah. They built the bypass.
Well, yeah, the bypass is built. The bypass is built the first year after the cement plant started. They got started on what we call the bypass. I think that's 89A. Up around Cottonwood and Clarkdale, so they did not have to go through downtown. But the last load, it was just about 84 or 64 when the 17 was built, so they could take the last load or two up 17 instead of having to go through Oak Creek Canyon. Now, Bill Helm told me the only place that they ever got hung up going up Oak Creek Canyon was a few of them. Once in a while, somebody would hang up on Pump House Wash bridge right there. If they didn't hit it just right, they'd hang up there, and the rest of it didn't make. So, can you imagine going up Oak Creek Canyon now?
Yeah.
Woo! I won't even drive the car up to it.
I don't go that way.
40, 50, 60 years ago, I guess it was a little bit better.
Yeah.
But anyway, is there any questions on them so far?
Well, would anyone like to take a guess what the power usage is of the cement plant?
Oh, was that neat?
All right, so every month their APS bill is between $500,000 and $600,000.
Wow.
And that is not running the kiln. That's just running the other equipment. The kiln they power now with coal, and they use 400 tons of coal a day, which just railroaded in from Gallup.
Yeah.
Like I say, when Halliburton was going to put the plant in, there was no natural gas in the Verde Valley. So when American Cement bought it, they had the gas brought in. When they come into the cement plant, they just continued on over to Sedona. And the first year, every time we've had a real cold night, we'd have to shut down and kill, so Sedona would have enough gas for heat. And that was very, very expensive, shut down a kiln and then heat it back up. So the second year, they put in a 610,000 gallon tank and bought crude oil at $4 a barrel. Well, the next year, $4 a barrel went to $16 a barrel, so that wasn't very good. Then is when they went to coal, and they've been burning coal ever since. At one point, about 85, they got permits and everything to burn tires, and they could have done it. They could have burned tires, but the environmental impact on it was so great, that it was so expensive, just checking everything, that it was not feasible. So that was out. So they're still burning coal, but they're thinking and looking for something else. I understand that.
But the present-day cement plant, their Energy Star rating, in order to get an Energy Star rating from the government, you have to be at 75%, and their rating is 97%. I mean, they have really gotten very efficient, used everything well. They have, in 1996, I think they got the award for the safest plant in North America. They, their safety things are really, really strict. And environmentally, they have so much cleaned everything up. Because it used to be, when you lived in Clarkdale, you had a lot of ash and cement dust and everything, and there is not that big a problem. You can walk around there now and not be covered by ash or anything else.
It's extremely clean, extremely clean. You can go in the ball mill and eat off the floor if you want to. It's clean. That brings up another thing there. When I was there, the ball mill was usually at least ankle deep in dust. You hit a building like that and you just cover everybody. But now they put in, we always had dust collectors and dust control, but it wasn't as efficient as it is now. They spent about $20 million when they did the rejuvenation. $20 million just strictly on dust control alone. So it's a very clean plant, very clean.
Just to give you an idea how big those trucks are, I mean, they're 100 tons, which is, to me, just a number. But recently, they wanted to take one of those trucks to Phoenix because it needed to be worked on. And when they checked with the city, well, they said you can't take it over 260 because 260, they're just laying the new road and it's too heavy. It'll damage the brand new road. So then they thought they'd take it through Cornville and get to I-17 that way. But they said, when you cross that bridge, that 100-ton truck is going to damage the bridge. So it's going to cost you $30,000 just to cross that bridge so that we can repair it when you're done. So they decided to wait until 260 is finished to take that truck out.
Where can you see this from? What road? I don't know where it is.
They go on 89A through Cottonwood when you turn left.
Okay.
At where Safeway is on one strut. When you turn left there and just go up and you'll see it all in Mom.
It's
There's approximately, at the high peak, there's approximately 135 hourly men work there. And then CTI, a lot of people think CTI and cement plant's all the same thing, but it's not. It's not. CTI is a completely different company. They haul the cement, but they're completely different. there's 130 men at the very peak. And I think right now probably 100 hourly men, plus maybe 20, 30 salary people that work there. And it's been running, like I say, it's been running since 59, and somewhere in the 60s, I believe it was, or maybe early 70s, they had a fatality, and it was his own doings. They seen him out there, and you seen the reclaimer rake. I don't know why you saw it, but anyway, he had to raise that reclaimer rake. So the crane boomed over, picked it up, and the guy was the lead man on that crew. He put the choker on it. Well, they got it up just about a foot high. The choker broke. The block come back and hit him in the head.
Oh.
That was the only fatality there's ever been. There's been a very few, even lost time accidents. Very few. The company used to. They don't anymore, I don't believe. But they used to give us a big picnic party, and they furnished everything for our whole families every year if we had no lost time accident all year. But I don't think they do that anymore, but they was really, really, really good that way for years. It's been a very good, when the Verde Valley, when the cement plant come into the Verde Valley, I don't know how many of you was here at that time, the mid-50s was pretty dead, because of the fact the smelter and the mines had shut down in the early 50s, and from then until the cement plant did come in, it was a pretty dead valley. I know, I was there, and you just get part-time work is about all you could get, and especially for a kid my age at that time. Yes.
So it's very prosperous now. I heard a rumor sometime about the plant closing. I don't remember when it was, how long ago it was.
They have material for at least 100 more years.
Yeah.
No end in
We don't
sight.
have to worry.
Good. That's good.
I don't think we have to worry about seeing it shut down, but there's a possibility that someday it will. I mean, everything ends at some time, I guess. But they've got 380 acres up there of material, and I think they've just kind of touched the surface.
How many people does it employ?
You said 130.
What was that?
130.
How many people? About 135, you said?
There's about, well, right now there's probably not too much over 100 hourly men, plus 20, 30 salary. So there's roughly 130 people work there, right in the plant. Then CTI, I don't know how many people they have, but they've got a workforce. And yes, sir.
So on the pollution dust control, is it a bag house operation?
There's bag houses. There's yeah.
Where
yeah.
do they haul that?
Pardon?
Where do they haul that? The dust?
Where they haul the dust?
Yeah.
The dust all goes right back into the system.
Okay.
Yeah, there's no.
Yeah, that makes sense.
At one time, when I first went to work there, we did haul dust out. And we had a canyon up there right above the cement plant we dumped dust into. I drove dust truck for several years, well, for several months when I first went there. And that brings up another question. I went to work there at $1.88 an hour. And pretty doggone good money, damn good money for me.
Yeah.
The first day I went on the truck there in the storage in the plant area at $2.01 an hour, and then I went into the quarry for a little while at $2.30 an hour, and now I think, hell, I don't know what they give. I'd be afraid to say. When I left there in 87, I was the highest paid hourly man in the plant, and I was making a little less than $15 an hour. But now I think a labor starts with that. So it's going on up. They're non-union now.
Okay.
It's non-union. I was very fortunate again. I've been lucky all my life. I've never been good, but I've been damn lucky. I left there in November '87, in August of '88, they had a strike that broke the union. And it broke a lot of families. It divided a lot of friends. And it was just a bad, bad situation.
Was it Teamsters Union?
No, cement, lime, and gypsum.
Okay.
I always felt like if I'd still been there, I could have talked them out of it. There was only seven votes to strike.
Okay.
And I always felt like I could have, but what if I hadn't have?
Yeah.
What if I hadn't have?
Yeah.
I'd been right there within a year and a half of retiring, and what would I have done? I don't know. I was just, thank God I wasn't there. So like I said, I was never good, but I've been lucky.
Do they haul the coal on the railroad that the Verde Canyon?
Yes,
And
yes,
how
all the
many
coal comes.
carloads a day do they have to bring in then?
Well, I don't know whether the train comes in every day, but it comes in every couple of 3 days.
Yeah,
Yeah,
clear full, I mean,
Yeah, there's a lot of coal cars coming in, like she said, it's 400 ton a
Okay?
Yeah.
day, so there's a lot of coal comes in there on that railroad.
Just to let you know what a huge part concrete is in our lives now. There's a figure here that kind of stunned me when I read it. That every American born today will need 50,274 pounds of cement and 131 million pounds of stone, sand, and gravel in their lifetime.
wow.
That's just, in terms of the roads, the buildings we have, and everything. From 250 years ago, there was none to how much we depend on it now.
Wow.
I'll show them, I'm sure of it.
And we have these out here if you want to help yourself.
Oh,
And here's a picture of just about the time it started that I'd love for all of you to look at. This is my personal picture. This is a cement plant picture. Greg St. Clair is the plant manager. Greg St. Clair has been plant manager for years. We used to, seemed like when I worked there, every 2 years we got a new plant manager. But Greg has been there, I don't know, he probably been there for 20 years or better. But his dad was PR man when I went to work. Well, not when I went to work there, but during the time I was there, his dad was personnel manager. Very good man, and Greg, after college, he ended up working there as an engineer, and then ended up plant manager, and he's been plant manager for several years, and he's been very helpful. And when I first started doing this, about 5 years ago, I had lots of notes and lots of everything, but my eyesight's gone to pot on that, so I can't see anything. I can't see it. My wife is my brain. And she is, for a fact. When I first started talking about cement, she said, well, why do you have to put all that rock and stuff in? Why don't you just make it out of cement? Well, here's some of her cement I made for it. That's all that cement was. And you can crush it with your fingers if you want to. So
it has to be that formula.
So anyway, it's been fun. It's been fun. This one here is just, it's cement and rock, gravel and sand. It's like it's supposed to be. But it's been fun. Her and I've had a lot of fun doing this. And we hope you guys enjoy it.
Yeah.
You got any more questions? I'll let her answer them.
I got one. My dad and his brothers owned ready-mix companies from the 50s through the 80s, and I worked at it. And we did a lot of precast with 1 or 2% calcium at it to cure it faster. So we would pour forms in 3 hours.
Yeah, you stand them up.
Yeah. So anything about like calcium in concrete, like when additives start happening, you mentioned oil and gypsum
And the lubricant.
in lubricants, but anything.
Well, and they add fly ash for like dams and things, because when they need it to really last,
Yeah.
you'd hate for your dam to crumble in 200 years. You know, So I think depending on what they're using it for.
Well, yeah, I'm talking about to speed up curing, like calcium
Cure
is used
faster,
for that. When they-
Yeah, I think some of them do add calcium to in certain projects now,
Oh, yeah.
but the cement plant does not.
Okay.
I don't believe they add it.
You can only use certain materials as liquid in cement for certain areas on account of the weather. Like back east, you put calcium chloride in concrete, it'll deteriorate the rebar.
Huh.
Is that right?
That's right, that's why they're repairing all these bridges. Because at one time, yes, it was a sand agent, but they found out later that also deteriorates the rebar. That's why the
Eat
pieces
the rebar up.
Yeah.
Well, that's not good. But this gentleman didn't care because he was gone.
They just used it in septic tanks.
Oh dear. Wow, is that good?
Probably not.
Well, anybody else got a question?
What happens if they decommission the coal mines?
Yeah, I've heard of the coal mines.
Well, if they do shut them coal mines down, it will eliminate their fly ash. But they are trying to find a location where they can buy a piece of ground that's got fly ash on it. And here a while back, I was told, I've got a grandson that's foreman out there. He was telling me that they had found a piece of ground, I think it was in Utah. I didn't pay that much attention to it, but I believe it was in Utah, and there was this big pile, and they thought this is it, so they bought it, and they found out that pile was the only fly ash on the place. So, you know, big companies make mistakes too.
Yeah.
That's something like I do, but they found out that was the only fly ash on the place, was that big pile that was piled there, and it looked good, and they bought the ground, and now they're looking for something else.
If they could truck it from Tennessee, they could get it there.
Well,
They have reservoirs.
yeah, there goes another railroad.
That's the problem with it.
Yeah, yeah. There's I guess there's a will, there's a way.
Yeah.
Yeah, it's been fun. Been fun.
Well, thank you very much.
Well,
Really,
thank you. It's been our pleasure.